Hi everyone, 21 News Chief Meteorologist Eric Wilhelm here with a look at the winter forecast for 2014-2015. This is an online video that is geared towards weather enthusiasts, weather hobbyists, other meteorologists perhaps around the region. Of course, I'm based in Youngstown, Ohio, and this forecast will be largely geared towards Northeast Ohio and Western Pennsylvania, but we'll take a look at kind of the broader view of the U.S. and actually the world as well, and show you what we expect to have happen this winter. So let's get right to it. First, a word, if I may, about the Farmer's Almanac. Uh, Chances are, if you're a weather hobbyist, a weather enthusiast, you know that the Farmer's Almanac is not a reliable source for long-range weather forecasts. What the Farmer's Almanac is great for is facts and figures, great illustrations, great explanations. It's a great learning tool. What it is not good for is forecasting. Unfortunately, a lot of people still kind of put a lot of faith in the Farmer's Almanac, count on it as a reliable source, and we just need to kind of get away from that mentality. Farmer's Almanac is for entertainment purposes only. If you want a real seasonal forecast, a real winter forecast, you go to a meteorologist such as myself, who is doing a little bit more than throwing darts at a dartboard, which is essentially what goes into the Farmer's Almanac forecast. So stay away from the Farmer's Almanac for winter forecasts. All right, before we get to this year, a review of last year. Last year, of course, in the Youngstown area was snowy and it was cold. It was the fourth snowiest winter on record with 90.1 inches of snow. And the average temperature, 23.7, made it a tie for the eighth coldest December through February period on record. When we look at these winter statistics, when we look at the snow totals, that is basically from October to April, the 6-month period in which it can snow. When we talk about temperature statistics, we're going to confine that to meteorological winter. In other words, December, January, and February, that 3-month period. So a little bit of a clarification there. 4.4 degrees below average is where we checked in last year with that temperature of 23.7. Remember that number, 4.4 below average, so we can compare last year to what we expect this year. Of course, we're not alone in Northeast Ohio and Western Pennsylvania when it came to the cold and snow last year. Actually, the harshest weather compared to average was in parts of Minnesota, Wisconsin, UP of Michigan, heading up into the prairies of Canada. That's where the winter last year was just absolutely one for the record books. It was not quite as extreme around the Youngstown area, but still, it was a remarkable winter, one that a lot of people will remember. The only real warm spot last winter, there were two spots, extreme southern parts of the U.S. around Florida and also out in the Southwest, including California. As far as a month-by-month breakdown of last winter, December started out, actually, the winter started out a little above average. For December as a whole, plus 0.3 degrees. So not much of a difference from average, but it was not remarkably cold last December. It was snowier than average. Last year got off to a fast start in the snow department. We had a big snow event at the end of November, not far from Thanksgiving. And then December was also pretty snowy with 20.5 inches. January is when we really started to sink into the deep freeze. 6 degrees below average for the month of January last year. One of the coldest Januaries on record here in Youngstown. And it also was snowy, 23 inches. That's about 6 inches above average for the month of January. February, in many respects, was even worse. It was 7.5 degrees below average in February and even snowier than average with 23.4. So that 2-month shot of January, February in 2014 was just remarkably consistently cold and snowy. The thing that I remember most from last winter was just how unrelenting the cold was. A lot of times, cold snaps break. You get a couple of mild days, maybe even a 50-degree day, but it seemed like last winter in January and February, we had very, very few of those kinds of breaks. All right, the winter forecast has a lot to do with not the atmosphere, but the oceans, believe it or not. What is going on with water temperatures in the oceans? That includes the Pacific, the Atlantic, and yes, even the Indian Ocean. The oceans and the atmosphere have a very intimate relationship. The oceans, a lot of times, are the driver of what occurs in the atmosphere. Those two things are very closely related. So as we take a look at the world and what the water temperatures are like, we're looking at anomalies here. In other words, the water temperature change or difference from average. Where you see the red colors, that of course would be above average water temperatures. The blues are below average. And in the Pacific, a couple of important things here for the winter forecast. We have this pool of above average temperatures in through here. This is an emerging El Nino. Some of you may be familiar with El Nino, some not. Of course, El Nino really became kind of famous in the 90s because we had an extreme El Nino year back in 1997 into 1998 that became kind of a worldwide weather story. It was so strong and it influenced weather patterns so greatly that there were a lot of fatalities across the world blamed on El Nino and what it did to the weather patterns, lots of flooding and that sort of thing. Well, this year's El Nino, thankfully, is not going to be a blockbuster record-setting El Nino. Two things about the El Nino. One, it's going to be a weak El Nino, not a real strong one. Secondly, it's a typical El Nino. You see the warmest waters kind of banked up against the coast of South America. This year, the warmest waters compared to average will actually be more towards the central or east central Pacific, and the placement of that warm water is important. And I'll show you why in just a second. The other important thing about the Pacific, we have all of this warm water in the Gulf of Alaska and banked up against the west coast of the U.S. The location of that warm pool of water can influence weather patterns around the eastern Pacific into North America, and that has a big influence as to what our thinking is in terms of the upcoming winter forecast. In the Atlantic Ocean, warm water off the coast of the Northeast, and then a cool pool out here in the central or east central Atlantic Ocean. So all those things are very important, and the forecast temperature anomalies for the winter are fairly similar to what they look like now. The El Nino will continue to strengthen. It's barely an El Nino right now. It's almost neutral even, but a weak outside chance of a moderate, but mostly a weak El Nino expected to emerge in the Pacific Ocean this winter. So a large part of the winter forecast process is going back into the record books and finding what we call analogs, or years that have a very similar setup to this year in terms of water temperatures, the placement of warm pools, cold pools, and other things like that. So we go back and try to find years that match this year. And so then we look and see what those years were like. Okay, you had a similar setup to this year. Was it a cold winter? Was it a warm winter? Was it a snowy winter? Et cetera, et cetera. Well, going back to 1950, this is the list of the years, the winter seasons, if you will, that are the closest match to this year. 1958, 1959, 69, 70, and then two very, very cold and snowy winters are on this list. At least for eastern Ohio and western PA. That would be the winter of 76, 77 and 77, 78. We had back-to-back really bad winters. 86, 87, and then a few more recent years, 2002, 2003, 04, 05, and most recently 2009, 2010 had a fairly similar setup to this year. Most of what this list has in common, a weak El Nino, some years on this list, that weak El Nino was based more towards the central Pacific than the eastern Pacific. There are a few other things that go into creating this list, but the main driver is the El Nino. All right, so in those winters, what happened? Here's the temperature anomalies for December in those years. As you can see, a definite, easy to pick out pattern here, warm in the west and colder than average in the east. And overall, the coldest weather compared to average in the east was actually right around the Great Lakes in those years when you average them all together. Not to say every December in all of those years was cold, but when you throw them all in and average them, you get this picture. It was colder than average. January. This is strongly influenced by those two back-to-back remarkably cold Januaries in the 70s, 77 and 78. That's why this map looks quite a bit bluer. But again, we're factoring in all of those years, and so you definitely, you see the pattern here. It's cold weather east of the Rockies, warm weather in the west. And then in February, overall, it's not as dramatic looking. It's certainly colder than average is the overall flavor here from the Front Range of the Rockies on east with the Pacific Northwest warm. Again, keep in mind, not every February in those years was colder than average around Youngstown, but a lot of them were, and you factor them all in, and it's painting a cold picture. Now, in terms of precipitation in those analog years, one thing your eye is drawn to here is it was drier than average in those winters in a big chunk of the Midwest down into the Mississippi Valley, and then the lower Ohio Valley as well. When you average them all together, precipitation amounts were pretty close to average or normal around Youngstown. You can kind of visualize where the storm tracks were in these analog years. A general track like this: Southern California, deep South Texas, heading into Florida, and then a lot of storms probably came up the coast. And so you see some above average precipitation amounts showing up in the analogs along the East Coast, but definitely a dry picture in the Midwest, west of Youngstown. So how does this break down for Youngstown specifically? Let's look at the temperatures in our analog years. 0405 was a pretty typical winter, not far off the average, but the other three listed here definitely colder than average, and 77, 78 by a lot. And then the other four, 86, 87, one of the exceptions, slightly warmer than average, but 76, 77, warm or coldest winter on record in Youngstown, minus 9.2. 69, 70 was also extremely cold. 09 into 10 was a little colder than average. So you get the idea here. With similar setups to this year, a lot of cold winters. Total snowfall amounts, this is where things can become a little more variable. I just showed you that map that showed Youngstown, when you average together our analog years, there's not a real strong signal either way. 0405, somewhat snowier than average. 58, 59, not as snowy as an average winter. And then 77, 78, and 09, 010 were above average, but not by a ton. We're talking 9, 10, 11 inches. 0203, snowier than average by about 14 inches. Not real remarkable winter in terms of snow in 69, 70. And actually, that extremely cold winter in 76, 77 was not snowy. It was below average. Those cold air masses plowed so far to the south that storms could not get very far north. So it was actually a pretty dry winter, despite how cold it was. And then just a slightly above average winter, 86, 87. There's not a real strong signal here in terms of the snowfall. But analogs aren't everything. We also look at, hey, what's happening right now as we're making the forecast in October? What is going to happen in the future in terms of what the computer models see? We use computer models to predict the weather for tomorrow. We can also use them to predict what can happen on a seasonal basis. One of the things that is kind of interesting, and there's a lot of emerging research about this, the depth of the snowpack in Siberia, over in Russia, and the speed in which that snowpack expands southward during the start of the snow season, October, has a lot to do, it seems, that's the emerging consensus in the research, it has a lot to do with what type of weather pattern evolves in the winter, especially over North America and the Atlantic Ocean. One of the things the research is strongly showing is that a deep snow pack, a rapid buildup of the snow in Siberia, an expansion southward, can result in what we call a blocking pattern across the Atlantic Ocean during the winter season. When this block sets up right around here, around Greenland and into the northern Atlantic, that can just act like a traffic cop, putting up a stop sign and keeping cold air locked into the eastern U.S. And your chances for some snow events go up as well, particularly along the East Coast. So there's a lot of research going into that, and this year, the snow extent in Siberia, the speed in which it's expanded, are very impressive. So that's a strong signal that we're heading towards a potential winter with a lot of blocking in the Atlantic Ocean. Long-range climate models, as I record this at the end of October, are kind of all over the map in terms of what is predicted for the winter. Despite all of the clues I've just shown that pave the way to a cold winter, there are many climate models that are not giving us a cold winter. In fact, here's January, the January forecast on the CFS, Climate Forecast System model. This is a US-generated model. Look at all the warmth across North America. These models have a track record of succeeding sometimes and sometimes busting pretty badly. A lot of them busted badly last year. Last year, a lot of models did not see the cold and snowy winter coming that eventually did occur. So, but some of them get it right some of the time. The skill in which these models, the skill exhibited by these models has increased in recent years. The fact that some of them are still predicting a warm winter does give us a little bit of pause. It stops us from going gangbusters and saying, hey, this is going to be another tremendously cold and snowy winter. The models are what is preventing us from saying that at this point, because other signs are pointing in that direction, that it's on the table that we have a memorable winter. So here's the forecast. You've waited 15 minutes. Here it is. For the U.S., we're looking around Youngstown at -3 in terms of the temperature difference from average this winter. Remember, last year was -4.4. So the takeaway is this year will be colder than average, but not as cold as last winter. Now, where could we go wrong with this? A couple of things. If the climate models have no clue and a lot of the other signals end up being right, this winter could equal last winter, or it could even be worse. That's on the table. I don't think that's necessarily likely, but it's on the table. So we're kind of, we're positioning our forecast kind of in between what could happen on the conservative end, which is the climate models are cluing on. It's probably not going to be a tremendously cold winter around here. The other extreme is the climate models are clueless. Look at all the other signals saying, hey, cold, 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 real cold. We're kind of in between that. We're predicting a cold winter, but maybe not quite as cold as last year. As far as snow, this is where predictions are tough, because one storm can make the difference. You could be plodding along, your forecast is doing just fine, and then all of a sudden on February 28th, you get 15 inches of snow, sending your snow prediction out the window for the winter. So this is tough. These are typical winter storm tracks. In Youngstown, typically we get our heaviest snowstorms from this track right here. Storms emerging from northern Texas, Colorado, Kansas, and then sort of tracking across the lower Ohio River Valley and out the mid-Atlantic states. This is far enough south that the cold air stays locked in, but it's close enough to us that the best moisture gets in. This could be the kind of winter, based on a lot of different things, that features a lot of East Coast storms. This could be a pretty big winter for, central Pennsylvania, upstate New York, away from the immediate coast, but closer to the coast, with a lot of tracks that do this, coming out of the Gulf of Mexico, riding up the East Coast. Typically, that type of storm track does not bring Youngstown a big snow event. We're kind of on the fringes of a lot of those types of storms. So since the pattern may favor those more East Coast events, that, along with looking at the analogs, and you remember the analogs don't point to a real snowy winter, we've concluded that overall our winter forecast should look like this. These snow totals are not far from average for a winter season. In some places, a little above average, but overall, this is not, a strong signal either way. It's not a map that shows a tremendously snowy winter. If you live in northern Trumbull or northern Mercer County, you're used to seeing 70+ inches of snow each winter. Around downtown Youngstown, Austintown, Canfield, Struthers, Poland, our typical winters 50 to 60 inches, and maybe closer to 50 in a typical winter. So we're in the range of 50 to 60, allowing for the possibility of a somewhat above average winter, but not as much as last year. The Youngstown Warren Airport, where the records are kept, 90 inches last year. The airport's in through here. We have the airport getting 60, maybe 70, at or above average, or slightly above average, I should say. Now, what could go wrong here? A great number of things. This forecast, the snow forecast, we have a lower degree of confidence in than the temperature forecast. So keep that in mind. One snowstorm can mess this up. One snowstorm that was supposed to hit but doesn't. It could have been a blockbuster. And so because we missed it, we end up getting a below average winter in terms of snow. That's always a possibility. Snow forecasts are a bit of a crapshoot, but I think the odds favor it being a lower winter, a less snowy winter compared to last year. All right, thank you for sticking with me and for watching our winter weather forecast. This will live online in infamy. Come back and watch it in March, see if I was wrong, see if I was right. Thank you for following me and the rest of our team on social media, Facebook and Twitter included. Have a great and safe winter season. Good luck out there, and we'll do this again next year, and we'll review winter of 2014-2015 and see where we went right or went wrong.